Today we're going to be reading chapter 26, section 1. You can find this on page 683. Conventional energy resources. What kinds of activities do you engage in each morning? Do you turn on lights or run water for a shower? In the kitchen, you might toast bread or use a microwave oven to heat up your breakfast. You may ride a bus to school or drive a car. All of these activities depend upon energy. Where does most of the energy that you use each morning come from? The energy that humans and all other organisms use comes mostly from the sun. Transfer of solar energy. How is solar energy used by organisms? Green plants, protists such as algae and cyanobacteria, are producers that capture the sun's energy in the process of photosynthesis. In these photosynthetic organisms, solar energy is used for maintenance, growth, and reproduction. Whatever energy is not used right away is stored by the organisms. When consumers eat producers, they use that stored energy from their own life processes. For example, when you eat a breakfast cereal made from grain, such as oats or wheat, as illustrated in figure 26.1, you are consuming the energy stored by those green plants. In this way, trapped solar energy is transferred through the food chains found in most ecosystems. A food chain is a model that shows how solar energy flows from the sun to producers and then to consumers in an ecosystem. Humans also need energy to keep them warm in cold climates, to cook food, to pump water, to grind grain, and to provide light. The energy for all of these purposes also comes primarily from the sun. Traditional sources of energy, such as wood and peat, are derived from producers such as plants. Even gasoline and kerosene are derived from decayed organisms that first obtained energy from the sun. When organic materials such as these are burned, the energy stored in them is released. Traditional sources of energy. Do you live in an area that has 4 seasons each year? As you can see in figure 26.2, some people live in climates that are very cold for part of the year. Humans have been able to survive in such cold climates primarily because of their ability to alter the environment to meet their needs. Living in cold areas requires humans to use energy to provide heat. Most humans also use energy to provide light and to cook food. The energy for all of these activities is provided by fuels, which are materials that are burned to produce heat or power. Probably the earliest use of fuels occurred when humans found pieces of wood that had been struck by lightning and were still burning, and then used them to start fires back at their homesteads. Archaeologists have discovered fire pits in caves that provided evidence that humans burned wood to cook their food many thousands of years ago. Traditional fuels, including renewable resources such as wood, dried field crops, and dried fecal material from animals such as cows and bison. In fact, many material that is in good supply and also burns can be used as fuel. The total amount of living things in an ecosystem is its biomass. Thus, fuels derived from living things are called biomass fuels. In many developing countries, biomass fuels are used to provide energy for cooking and heating. By far, the most commonly used traditional biomass fuel is wood. Today, wood is the primary source of energy for more than half of the world's population. Wood. Humans have been using wood as an energy source for thousands of years, while wood is currently the primary source of energy for only about 4% of households in the United States. Roughly 1.5 billion people throughout the world use wood as their primary source of fuel for heating and cooking. Many of these people live in developing countries, which use half of the world's wood supply. Unfortunately, the need to use wood as a fuel has led to deforestation in many areas of the world. As the forest near villages are cut down for fuel, people travel further and further away to gather the wood they need. In some parts of the world, this demand for wood has led to the complete removal of forests, which in turn has resulted in erosion and loss of topsoil. In industrialized countries such as the United States and Canada, trees are cut down for lumber and paper production rather than fuel. However, the use of forest resources can have the same negative impact on the environment. Field crops. When wood is scarce, humans use other materials, including field crops, as fuel. The simplest way to use field crops, such as corn, hay, and straw, is to burn them directly. Crop residuals left after harvest, including the stalk, hulls, pits, and shells from corn, oats, rice, wheat, and nuts, and other sources of energy. All of these can be burned to provide heat. Crops and their residuals are most commonly burned for fuel on farms and in homes. Fecal material. Feces are the solid waste of animals. In many cases, dried feces contain undigested pieces of grass that help the material to burn. Fecal material from cows often meet the energy needs of people in the developing countries that have limited forest resources. People who live in villages in India, Pakistan, and Afghanistan collect animal dung for fuel and dry it on the outside walls of their stables or compounds, as illustrated in Figure 26.3. Peat. Bogs are poorly drained areas with spongy, wet ground that is composed mainly of dead and decaying plant matter. Plants in bogs include sphagnum moss, which forms large mats on top of the water. When plants in a bog die, they fall into the water. Bog water is acidic and has low levels of oxygen. These conditions slow down or stop the growth of the bacteria that decompose dead organic matter, including plants. As a result, dead and partially decayed plant material builds up on the bottom of the bog. Over time, as the plant material is compressed by the weight of water and by other sediments and that accumulate above it, becomes a light, spongy material called peat, shown in Figure 26.4. Most of the peat used as fuel today is several thousands of years old. Peat has been used as a low-cost fuel for centuries because it can easily be cut out of a bog, drained in the water, and then burned directly in a stove or furnace to produce heat. Highly decomposed peat burns with greater fuel efficiency than wood. Today, peat is still used to heat homes in Ireland, England, parts of Northern Europe, and the United States. Fossil fuels. Peat is one of the fossil fuels, which are energy sources that formed over geologic time as a result of the compression and partial decomposition of plants and other organic matter. Although peat and all fossil fuels originally formed from once living things, these energy sources are considered to be non-renewable because their formation occurred over thousands of or even millions of years. The formation of peat is the first step in the development of coal. Fossil fuels also include coal, natural gas, and petroleum. The high concentration of carbon and hydrogen in fossil fuels makes them very efficient energy sources. Most industrialized countries of the world today, including the United States, depend primarily on coal, natural gas, and the petroleum to fuel power plants that provide electricity and to fuel vehicles. You can find out how one oil company preserves the environment while prospecting for fossil fuels and the science and the environment feature at the end of this chapter. Although these fossil fuels are diverse, all of them originate from organic matter taped in sedimentary rocks. Coal. During periods of coal formation, tectonic plate movements caused some landmass to move near Earth's equator. As a result, these areas experienced humid tropical conditions that supported abundant plant growth. Generations of swamp plants, such as ferns and sedges, grew in the warm tropical swamps. As each generation died, the organic material settled in the bottom of the swamp and became covered with subsequent generations of dead plants. The limited supply of oxygen was used up quickly, which resulted in a slow rate of decay. Over time, oxygen and hydrogen were lost from the organic material, and the concentration of remaining carbon decreased. Eventually, this compressed organic matter became coal. Coal can be classified according to the amount of pressure under which it is formed and the amount of time involved. Figure 26.5 shows types of coal. When peat continues to be compressed, it becomes a type of coal called lignite, a soft brown, low-grade coal. Over time and under increasing pressure, lignite develops into the higher grades of coal as it changes from soft bituminous coal to a hard anthracite, the highest grade of coal. Carbon concentrations in lignite are generally around 40%. In bituminous coal, carbon concentrations can be as high as 85%, and in anthracite, these concentrations reach 90 to 95%. The higher the carbon concentration, the hotter and cleaner the coal burns. Anthracite is the most efficient and most cleanly burning coal. However, less than 1% of the coal reserves in the United States are anthracite. Most coal reserves in the United States are bituminous coal. Thus, many of the electrical plants in the United States burn in this type of coal. When bituminous coal burns, it releases carbon and sulfur and nitrogen oxides into the air, causing air pollution. Although lignite has a lower sulfur content, less than 1%, and is less expensive than bituminous coal, lignite is a less efficient fuel. More of this must be burned than other fuels of coal to provide the same amount of energy. Petroleum and natural gases. The word petroleum comes from the Greek word petra, means rock, and the Latin word oleum, meaning oil. Thus, petroleum was originally known as a rock oil. Today, the term petroleum is used to refer to the natural crude oil found underground and on Earth's surface in natural steeps, which are areas on Earth's surface where shallow deposits of crude oil ooze upward into pits of creeks or along beaches. One such seep is illustrated in Figure 26.6. Crude oil is a mixture of compounds of hydrogen and carbon called hydrocarbons, which can be burned to release energy. Crude oil that is collected on Earth's surface or pumped out of the ground is refined into a wide variety of petroleum products such as gasoline and kerosene. Most geologists hypothesize that oil originating organically in a manner similar to the formation of coal millions of years ago, such as Earth's land surface was covered by shallow seas, rivers carrying mud and silts, along with other sediments emptied into these seas. Organisms that died in or near the water became part of the sediment load and fell on the bottom of the seas. As layers of sediment acclimated, they were pressed down by the weight of overlapping layers and eventually became sedimentary rocks. Most scientists hypothesize that crude oil and natural gases originated with one living organism, partly because sedimentary rocks associated with oil deposits such as sandstone and shale contain fossils of ancient organisms. Also, because little oxygen could reach the layers of organic material at the bottom of the seas, bacteria that did not require oxygen particularly decomposed the accumulated organisms and released a waste product called methane, which is one of the components of natural gas. Migration. Crude oil and natural gases migrate sideways and upward from their place of formation. As they migrate, they move through the pores of permeable sedimentary rocks such as limestone and sandstone. These pores in permeable rocks are the reservoirs in which crude oil and gas accumulate. As the oil and gas rise upward, they displace some, but not all, of the water in the originally filled the pores. You can find out how oil migrates in the mini lab on the previous page. Oil and gas continue to rise until they reach a barrier of impermeable rock, such as slate or shale, that prevents their continued upward movement for the petroleum. In other petroleum traps, the natural gas forms a gas cap above the oil, but as high pressures, the gas may form a layer below the crude oil. Geological formations such as faults and anticlines can trap petroleum deposits, as shown in Figure 26.7. Because most geologists accept the The hypothesis that oil and natural gas originated with the sedimentary of one's living organisms. Search for crude oil and natural gas often began in areas with thick beds of sedimentary rocks. Today, geologists search for oil deposits using remote sensors, magnetometers, and seismographic equipment that create subsurface maps.